Hello, let's talk on these elements and the symbols. First, you are going to define specifically what is an element, and then you see the ways of naming and how these symbols are assigned to various elements. So let's start seeing this. What is an element? Simply, you can say that uh, an element can be defined as a substance that cannot be split or cannot be separated into two or more simple substances. So an element is simply that substance that is made up of only one kind of atom. So example for elements, example hydrogen element, helium element, oxygen element. They're just few of the examples. So let's see the names and symbols of elements. What is a chemical symbol? You can define a chemical symbol as a way of representing these elements using initials or letters. So let's see some of the rules for assigning these chemical symbols to the elements. The first one is that each element is given a different symbol to represent it. So you can find maybe uh, two elements having the same symbol. No, each symbol will represent a different element, and that's why each element has specifically given a different symbol to represent it, so it doesn't bring confusion. The second one is that some elements are represented by two letters. Example, maybe this calcium, you can see this Ca, that's how it is represented. Cl for choline, and the others are just few of the examples. You can find more of the elements and how are represented in the periodic table. So if two letters represent the element, now the first element is always in a capital letter and the second one is always in a small letter. So you can't write both of them in caps or in small letters. So that's how you have to represent the letters. Example, maybe album, you can see A starts to be written as a capital letter, then R as a small letter. Then also example, helium also, H starts as a capital letter, then E as a small letter. Moving on, so other some elements of their chemical symbols derived from Latin names. Why they were derived from Latin names? Because in order to avoid confusion, because some elements maybe had the same symbols when you can if you just see based on their names, they could have the same symbols. So instead of writing them the same chemical symbols, they derived their chemical symbols into from these Latin names of these elements. Example, sodium, its chemical symbol is Na, and that Na that is derived from a Latin name. So those are just of the few rules that are used for assigning the chemical symbols to the elements. Moving on, you see the compounds and the mixtures. What is the compound? You can say simply that a compound is a substance that contains two or more elements specifically combined together. So if these elements are combined together chemically, that's how we get a compound. So example of compounds are like water. Water is made up of hydrogen atoms and the oxygen atoms. So those are, as we said, elements are made up of single atoms. So the combination of those elements chemically together, they form a compound. Now a mixture is something that it contains or contains two or more elements not combined chemically. So a mixture is basically a physical mixture, while the compound is the chemical mixture. So you can see there are differences as follows that the Some of them are how I explained in the table. With mixtures on the left side and compounds on the right side. So let's start seeing the first one, that the compounds of a mixture can be separated by physical means. Since the elements are combined physically, they're not combined chemically. So basically also the ways of separating these has to be physical means. Example, maybe filtering. This is like separating liquid and the solids. Magnetic separation is the use of magnet to separate the mixture. Decantation is the phase allowing the settling of the particles, then separate the liquid and the solid particles. While the compounds, these can be separated by chemical means only. Such chemical means may include the example, uh, those that require the altering of the chemical structure of the compounds. So the other difference is that the composition of mixture can vary widely, or you can say that the composition of a mixture can be of any proportion. Example, a mixture may be of 2 grams of salt of sand with 1 gram of salt or vice versa. It doesn't matter. While the compounds are their combination or their composition are fixed in a certain amount. Example, there are always 2 atoms of hydrogen to 1 atom of oxygen in a molecule of water. So basically, the composition of a compound is always in a fixed way, while the mixtures it is in a varied way. The third point is that the properties of a mixture are the sum of the properties of individual constituents of the mixture. This means that to obtain the properties of a mixture, you definitely see the properties of the individual constituents of that mixture, while the properties of a compound are quite different from those of the constituent elements. Example, water is a liquid, whereas the constituent elements, the hydrogen and the oxygen, are both gases. So you can see there is a difference of property. And the fourth one, say that the new substance is no new substance is produced as the mixture is forms. So there's no new substance is produced in a mixture, while in a compound there's a different new substance that is produced after the combination. So those are just a few differences of the mixture and the compound. Moving on, let's see more of the concept of a mixture. Here we see specifically more what is a mixture. As we said before, that a mixture is something that contains two or more substances that are combined physically or not combined chemically. So the substance may mix up completely or they may remain separately. Now, the formation of mixtures. Mixtures can be formed from different substances in two major ways. The first one is that is the homogeneous mixtures, as well as the substances are totally mixed together uniformly. Example, the solution of salt and the sugar in water is a homogeneous mixture, while the heterogeneous mixtures, these are the substances remain separate and the one substance is spread throughout the other as small particles, droplets, or bubbles. So all emulsions and the suspensions fall under this category. So examples of these heterogeneous mixtures include the suspensions of insoluble solids or oil droplets in water. Let's see the classification of mixtures. Mixtures can be classified as follows. Can be classified as solutions, suspensions, or emulsions. Let's see solutions. Solution is a uniform mixture of two or more substances. So such mixtures can be, example, solid in liquid, liquid in liquid, liquid in gas, and very rarely gas in gas. So example of solid in liquid is a solution of sugar or salt in water. Now, the solid that dissolves in a liquid is what we call a solute, while the liquid which that is solid dissolves in is called a solvent. So specifically, you can say example, sugar and salt. Solids and water is a solvent, and the water is a universal solvent. What is the universal solvent? Universal solvent is the solvent that can dissolve plenty much or uh, various substances of these solids compared to others. So that's why it's called the universal solvent. Let's see the suspensions. The suspension is a cloudy mixture of solid particles suspended in a liquid. So example of these are like this mud water. Mud water, you see that there is a mixture of water and those solid particles that form a, a cloudy mixture. So after some time, it settles and uh, the mixture can be separated like that. Let's see the difference between the solutions and the suspensions. Solutions first they are transparent, while the suspensions, as we said, that is cloudy, so it's opaque or not clear. The second one is that solutions are homogeneous. Uh, this means that the solution is a homogeneous mixture, as we already said. Homogeneous mixture forms the same properties, while suspensions is the heterogeneous mixture. The third one is that the particles completely dissolve in the solutions, while in its suspensions they partially dissolve. This means that the particles are separated on standing. The fourth one is that the components separated by evaporation in solutions, while the components in suspensions are separated by filtration after the sedimentation. What is sedimentation? Sedimentation, this is the obtaining of those sediments by allowing the water to come or to stay cool for some time. Let's see the emulsions. Emulsion also is the cloudy mix of tiny droplets of one liquid is suspended in the another liquid. Example of these emulsions, the mixture of cooking oil and the water. So, hope it's clear. Thank you for listening.